Hello everyone, welcome back to my channel. I am Zach Peterson, and today we're going to be looking at a viewer question about BGA fanouts in Altium. Now, I recently did a video about 0.4mm BGA fanouts, but I got a great question from a viewer asking how to set this up in Altium Designer and actually implement these very fine pitch fanouts alongside maybe a coarser pitch fanout. So what we're going to do today is run over the design rules that you need to put into the PCB and how the automated tool works and sometimes how it doesn't work, and some workarounds that you can really quickly use to create very large BGA fanouts, including for very fine pitch BGAs. Let's go ahead and jump in and get started. So in this design demo, I'm going to show you how to apply some fanouts to a very fine pitch BGA, including in the cases where you can't get the fanout tool to work just quite the way you want to. There are actually some really easy paste tools in Altium Designer that you can use to create those fanouts, including with stacked, blind, and buried microvias. So first things first, I want to take a look at the viewer question that runs over the type of situation that we're looking at in a high density design. Let's take a look. Glenn Z writes, I've got a design challenge for you. Imagine you're building a board around a 0.35mm pitch wafer level package with just a couple of bypass capacitors nearby. On the real board, there will be many more parts, including a 0.8mm pitch 64 ball BGA plus QFNs and DFNs. Fab House has confirmed 3mm, 3mm line width and spacing via in-pad, laser drilled microvias, and 4mm drills. So if you were starting from a clean state with design rules and a stack up, how would you approach the fan out for this design? Now this is a great question. We actually talked a little bit about this in our 0.4mm fan out video, and you can find a link to that video in the description. But here we want to look at not just how to select or place the microvias for this fan out, but we also want to look at the design rules that are needed to try to get the tool to outline this automatically, as well as how to apply that fan out directly to the footprint in your PCB layout. Now, sometimes Altium has a little bit of weird behavior when you do the fan outs. It just depends how you set up the design rules, and sometimes the design rules are conflicting and it's difficult to get the fan out tool to actually do the fan out. Now, the fan out tool does work if you set it up and use it properly, but if you want to get around using the automated fan out tool, there is another way to create that fan out very quickly, including for very large BGAs that have, for example, 1,000 or more pins. So I have a project open in Altium Designer where I'm going to show you how to do this. Now this project that I have open is my NRF52 package module, and I talked about this a little bit in another video, and this is an in-progress project. So I think this is a perfect time to look at how to do the BGA fan out and how to set up the design rules to do this successfully. So here we have two BGAs. Here we have the NRF52 wafer level chip scale package, and you can see here, if you're not familiar with this microcontroller, that this does have a 0.35mm pitch. Now we have another BGA in this design. Here you can see this BGA has a larger pitch. The pitch is 1mm. So it's not exactly the same as Glenn Z's question proposes, but it is pretty similar. Now, whether you use the automated fan out tool in Altium or whether you do the fan out manually or whether you do a paste array, you are going to have to define the design rules and the stack up correctly to ensure that the board can be manufactured, that you have the right via spans, and that you don't create design rule violations in the process of using the fan out tools. So first, let's take a look at the stack up. Here in this design, in the stack up section, you can see I have a 6-layer stack up. It has about 1mm total thickness, and you can see here we have pretty thin layers that you would typically use for an HDI design. Here in the via type section, you can see what my vias are. Here we have blind and buried microvias, and then we have a central core via that we can use to connect the top and the bottom half of the board. And then of course we have through holes, as you can see here. Now this stack up is pretty basic. It is a standard HDI stack up, and note the layer thickness here. This layer thickness is going to confine the via diameters that we can use in this design and still ensure that those microvias are going to be highly reliable. So here in this example, you can see that our HDI buildup film layers have a 3mm thickness. That's going to limit us to using a 4mm diameter drill, or at the very smallest, a 3mm diameter laser drill. So that's going to keep the aspect ratio for those vias at 1:1 or less, and that's exactly where we want to be. Now let's click back over to the PCB layout and take a look at the design rules that we need to do this fan out. So here in this design, you can see that I've set up some design rules that are specific to the BGA. I've also implemented a width rule that sets our preferred width to be 3mm, which then matches the line width clearance values that we saw in the viewer question. And then we also have some via styles that are applied to specific types of vias. Now here I've set one via style that can be applied to our blind and buried vias. We can set that with a custom query, just for example, using the is blind via or is buried via query. And then we can set this other via style to be for our through holes. Here I'm just going to leave the rule scope as all, and that will cover our through hole vias. Another very important set of rules is the fan out control. Now the fan out control here is specified in two ways, and you can see that one of these is using the within room query. And you can see here, if I just move the rules and constraints editor over to the right a little bit, you can see that room that I've drawn out around the NRF52 0.35mm pitch BGA. So that's where this rule is going to apply. We have another fan out rule, which is here just for general BGAs, and that's going to apply the standard dog bone fan out that you typically see on larger pitch BGAs. Now there's one final rule that we need, and it's located down here in the high speed section, and that is the vias under SMD rule. Now you can see here, there is a flag. If you click this to be true, this will allow vias under SMD pads within the scope defined up here in the top part of the dialog. You can see here that I have set this to be within the BGA room, so we'll only be applying via in pad here to this 0.35mm pitch BGA. So to get started with our fan outs, let's take a look at the 1mm pitch BGA. Now I want to start with this one because 1mm pitch BGAs and 0.8mm pitch BGAs have a large enough pitch that you can use through holes to do the entire fan out. So that's what we're going to do in this example. Now here in this example, we actually don't need the through hole vias in order to do the fan out, but if you have a larger BGA and you want to use the automated fan out tool, the process that you see here is the exact same that you would use for another BGA. Basically, you would just select the BGA, you can right click, go down to component actions, and then click fan out component. You'll need to select a couple of options here, and here you want to make sure that you uncheck fan out pads without nets, because if you check the fan out pads without nets option, it is going to take all of those netless pads and it's going to attach traces to them, which you don't need. You have no nets on those pads. So we want to make sure that we uncheck that box. And when you click OK, it's going to run through. It's going to place the traces over to those vias, and then it will also place those vias centered between these pads in the typical dog bone fan out. Now, like I said, not all of these pads have nets assigned to them because this is just a flash chip. And if you had a larger BGA like a microcontroller, you could just use the exact same process that I showed here, and it's going to apply the same type of fan out to that component. Now, what about our fine pitch BGA that you see here with this room assignment? Well, here, what I would prefer to do is to just place vias and then do a paste array. And this is going to allow me to automatically copy groups of vias across all of these pins, and then I can set my blind and buried stacked microvias on multiple layers in the stack up. So let me show you what I mean. So first, what I want to do is place a via. And I want to place my via on the very first via that we're going to route. So here you can see we're going to place a via right here on the SWD-IO pin. Now here with this via, once I've placed it, I can then copy this via automatically to every other pin in this row. And that's pretty simple. I just first copy this via, select the reference point right at the center of this via. Then I'm going to go up here to Edit and Paste Special. The next thing I want to do is use paste array. Now, paste array is a pretty powerful tool. It's going to allow us to basically paste a group of these vias across this entire row. And so you can see here that we need to paste 7 of these vias. And we're going to increment by basically the value of the pitch in this BGA package. So here, once I hit OK, you can then see here, it's going to allow me to select a reference where we start pasting that via array. I'm just going to click this row right here. And you can see here it automatically applies all of those vias. Now here, of course, when you zoom in, you'll be able to see that there are some vias that don't have any nets assigned. And of course, those vias don't have any nets assigned because there's no pad in those locations, right? Pretty simple. Now I'm going to leave these vias here for just a moment because we're going to use those vias to then paste another array in the -y direction so that we paste all the way down through the rest of these pins on this top layer. So here what I'm going to do is select all of these vias. I'm going to copy and select that same reference point right here on the left side. Then I'm going to go into Edit and Paste Special. I'm going to hit, again, Paste Array. And now you can see here that instead of setting up the paste array with an X spacing, I've set the X spacing to 0 millimeters, and I want to set the Y spacing to -0.35 millimeters. And that's going to ensure that those pasted rows are going to move down the BGA footprint, as you can see here in the layout. So here, when I hit OK, it's going to let me select a reference point. I'm going to select this pin. And there you go. You can see here it's pasted all of those vias here along this, this package. Now here again, you see that some of these are pasted without a net assignment. That's of course because if I delete these, you see that there's no pad in these regions. And so that's exactly what we would expect. Now if I just clear the design rule errors for just a moment, you can see here that we now have a Microvia fan out for our first layer in this BGA package. Now the way this is set up would be perfect for routing with 3mm line and spacing here on the top layer. Now here, if I just select one of these pins, you can see here I can set my width to 3 mils, and you can see here I can start routing out of these pins on the top layer. Now here with 3mm line width and spacing, I'm not going to have enough room to route from one of these pads up between these two traces unless my clearance is very small. So you can see here, if I just hit escape, you can see that we have a pretty small clearance here, which is just right at the limit of what we would be comfortable with. And you can actually see here, it's actually below 3 mils. So here we have a 3mm pad to center of trace distance, and that leaves less than 3 mils between the trace and the pad. So unfortunately, we wouldn't be able to do that with a 3mm line width and spacing constraint. However, we could go into layer 2, for example, and once we're on layer 2, if we just set this to single layer mode, we're then able to route out these pads in the internal layer, again with a 3mm line width, and then we can then repeat this via array on the next layer and route out from this next row. So in order to get this via array into the next layer, one thing that you can do is you can just select all of these vias. We're going to make a copy of them with this via as our reference point. And once I've selected these vias, I can just change all of these to microvia from layer 2 to layer 3. Then I can go ahead and paste the 1 to 2 layer vias right here in that BGA region. And you can see here we now have stacked microvias going down to layer 3. Now with this specific design, I would set this up to use just these 6 layers because this gets you all 3 layers of signal into these internal layers. Now you have to be careful with that because of course these IOs can overlap each other and they'll have crosstalk. And so if you're worried about crosstalk between the different layers, you should actually set this up with more layers so that you have ground in between these signal layers. Now, unfortunately, if you need to start interleaving ground between these signal layers, that's going to force you to go to a higher number of stacked microvias. And of course, the more microvias that you stack on top of each other, the less reliable your design could get. So you need to make sure that you work with your fabricator to get the geometry that is going to ensure reliability for these stacked microvias, and then figure out what the maximum number is by working with your fabricator. They should be able to tell you the maximum number that they can stack and still ensure reliability. Now for some designs, there's going to be a limit on the number of blind and buried microvias that you can stack, but not based on your fabricator's capability. It's actually based on the reliability testing from your own company. So for example, some aerospace designs will limit the number of stacked blind and buried microvias to a small number because of the reliability issues that are inherent in these microvias. In those designs, they may prefer mechanically drilled vias, and those are going to require a larger diameter, and that might preclude using a chip like this that we're seeing in the demo. Instead, you're going to be forced to use a larger pitch chip in order to fit those larger diameter mechanical drills. Building this type of design correctly requires figuring out the number of layers that you need, not just for the signal, but also for the ground that's interleaved between these signals. So make sure you do that work first based on your line width and spacing limitations, and then figure out the number of stacked blind and buried vias that you might need to use in this design. And remember, you don't always have to stack those blind and buried vias. You can also stagger them. That's going to also give you higher reliability, and you may be able to use a larger number of HDI buildup film layers in order to complete this fan out with this type of BGA package. Thanks for the question, Glenn. Hopefully this helps you understand the fan out approach for these types of fine pitch BGA packages. Remember, make sure to get your fabricator's input and approval for your stack up and your desired layer count before you start doing the BGA fan out. If you like this video, make sure to hit the like button, leave your comments and questions in the comment section, hit that subscribe button, and I'll see you in the next video, everybody.